So good evening, everyone. This is lecture number 2 in continuous and characteristic X-rays, and we are supposed to finish this topic here and today. I hope we can do it. In the last class, what we had seen the hard and the soft X-rays. Do we remember this hard and the soft X-rays?
Yes, sir.
Depending on their frequency. If the frequency is more, we call it hard X-ray. If the frequency is less, we call it soft X-ray. Do we remember this?
Yes, sir.
And we have seen that there are two characteristics of X-rays that we must control. One is the intensity of X-rays, and the intensity of X-rays actually means the number of X-rays. And how do you control the number of X-rays? By controlling the current in the filament. We remember this.
Yes, sir.
And the second thing was, how do we control the energy of X-rays? By controlling the potential difference. We call it the operating voltage or potential difference. We remember this. Now they are so hard and soft X-rays were classified on the basis of their frequency, but now there is the more basic um classification of X-rays based on their nature, how they are actually formed, or how what is causing these X-rays to come. And there we have two types of X-rays. The first type of X-ray is known as continuous X-ray. Now what are these continuous X-rays? You For NEET people, you don't have to really write anything about it. I'll just show you a diagram, and from that diagram you would be able to understand what is happening with this. You may not have to write this. If you wish to write it, you can write it. No one is going to ask you this. Very rare you will get a question on this, how these X-rays are formed. So how these X-rays are formed, as I told you, what is going to happen is you are having a target metal and you are bombarding this target metal with this electron. Do you see an electron here which is bombarding this target metal? Now when it is moving towards this target metal, there is a positively charged nucleus and this electron is negatively charged. So what will happen is, while it is going closer to the nucleus, it will get deflected like this. Yes or no? Once it gets deflected, it will lose its energy, and it will keep on losing its energy continuously. And therefore we have these X-rays which are emerging out continuously. These X-rays are known as your continuous X-rays. They are formed because of this electron losing its energy continuously. Do we understand this?
Yes, sir.
These X-rays are formed because of these electrons losing their energy, because of this electron losing its energy continuously, and hence they are known as continuous X-rays. You can write its production if you want to. It's also given there. If you want, you can write it. So because of this continuous losing of energy, you will have these continuous X-rays. Do you understand this?
Yes, sir.
Okay, just note them down. You can just draw the diagram, that is more than enough. No one, I have not seen a question that comes based on this in your exam. Only once I saw it. If you noted it down, please let me know.
Done, sir.
Boys,
Completed, sir.
okay. So now you have this continuous X-rays. Now, whenever we have this continuous X-rays, these X-rays are continuous. They are also continuous because we have all types of wavelengths coming above a certain minimum wavelength. So the next heading that we are going to write is minimum wavelength of X-rays. And whenever we're talking about minimum wavelength of X-rays, we are talking about minimum wavelength of continuous X-rays. Now, this minimum wavelength actually depends on the kinetic energy of the electrons. Now, if when do we have minimum energy? If the electron loses its entire energy then the wavelength would be lambda min, or you can say the frequency of X-ray would be lambda f max. Do we understand this? These electrons which is getting deflected, it loses energy. If it loses its entire energy, the wavelength that is emitted is known as lambda min, or the frequency is known as f max, because minimum wavelength corresponds to maximum frequency. Do we understand this?
Yes, sir.
Now, it has a kinetic energy half mv square. And how is this kinetic energy coming? This is coming because of the accelerating potential difference between the cathode and the anode. Do we understand this?
Yes, sir.
Because of this, we are having this minimum wavelength. So we write it as hc by lambda min, or you can write it as h into f max. From here, you can write the formula for lambda min. Lambda min will be hc divided by ev. If you put it in SI units, this is how it will look like. If you put in electron volts, the formula will become 12,400 divided by V, and the answer would be in Armstrong units. If you write the formula for frequency max will be EV divided by H. Hardly you will get any question on maximum frequency. You will only get, if possible, if there is a question, you will only get it on the minimum frequency. Do we understand this?
Yes, sir.
Okay. Have you noted it down? I'll give you 1 minute to note it down. Note it down and let me know so that we can move ahead.
Done, sir.
Boys?
Completed, sir.
Okay. Now, what are the important points that you have to note? So you can note them as important points. Only those important points are going to come in your exam as theoretical question. Point number 1. For continuous X-rays, all wavelengths of X-rays are emitted. Above what value? Lambda min. Do we understand this? Do we understand this? Lambda min only depends on we call it operating voltage. Operating voltage, that is your V, potential difference. Lambda min does not depend on type of target metal. Do we understand this?
Yes, sir.
And then you can remember the formula. Lambda min will be equal to HC by EV, or you can write it as 12,400 divided by voltage in Armstrong unit. Everyone is understanding what I am telling you, bacha?
Yes, sir.
Have you noted it down, beta? Abhiram? Okay. Then there are 3 or 4 graphs. If you can understand these graphs, remember these graphs. These graphs are coming straightforward from your equations that I have written here, bacha. Have you noted this down?
Yes, sir.
And this is the first graph. This is the graph between frequency max and V. And as you can see, frequency max is directly proportional to the operating voltage. Do we see this? Therefore, the graph is a straight line. Do we see this? Yes or no?
Yes, sir.
And this graph starts from 0. Remember this graph starts from 0, because sometimes they might give you this graph between log of frequency max, graph between log of frequency max and V. Remember, it cannot start from 0, because whatever with the value, log of something cannot be 0. That is why it does not start from 0. Do we understand this? Log of 0 is not possible. Do we understand this? Yes or no? No, yes. Then you might have the third graph. In the first 2 graphs, we talked about maximum frequency. So in the third graph, we will talk about what?
Minimum frequency.
Minimum wavelength. And the graph is rectangular hyperbola because lambda is inversely proportional to your voltage. And in the fourth graph, we'll talk about log. Log are very famous these days. The graph on logs. And remember, the graph looks like this because it has a negative slope. These are the 4 graphs. When they make your paper very tough, then they can give you these graphs. So please note them down. Tell me once you are done. If you have any problem in understanding these graph, bacha, please let me know.
Done, sir.
Boys, are we done? Okay, then there is one more graph that remains, and that graph is graph number 5 that tells us about the intensity and the wavelength. And you can understand from this graph what happens here. Very important graph. Graph between intensity of X-rays. Intensity of X-rays is plotted on the y-axis, and the wavelength lambda is plotted on the x-axis. As you can see in this graph, these 3 are the lambda minimum for different operating voltage. As you can see, when it is 30 kilowatt, when the operating voltage is 30 kilowatt, lambda min is less. When it is 20 kilowatt, lambda min increases. When it is 10 kilowatt, lambda min increases further. That means when the voltage goes up, lambda min comes down. Do we understand this? And
Yes,
when
sir.
the voltage goes up, the maximum value also goes up. So 30 kilowatt, we have the maximum intensity here. For this, maximum intensity decreases. For this, maximum intensity further decreases. And we can see that this graph is going till infinity. It starts from a minimum value. This minimum value depends on the voltage. Do we understand this? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to note this down. Let me know once you're done, bacha.
Committed, sir.
Done, bacha?
Yes, sir.
Girls?
Done, sir.
Okay. Then we move on to this question. It's a straightforward question. The minimum wavelength of X-ray is produced in a Coolidge tube, which is operating at a potential difference of 40 kilovolt, sorry, not watt, sorry. 40 kilovolt is how much? Straightforward question. You'll get straightforward question in this. For this X-rays, questions in JEE Main and NEET are of the same level because questions are so simple. So whatever question can come in NEET, they can also come in JEE Mains. It's as simple as that.
Sir, option A.
Option A. Let me. Boys, did you get the same answer? Option A, 0.31. That is correct. Absolutely correct. Boys, what about you? Are you getting the same answer? Boys are still struggling. Boys,
Yes, sir.
got the answer?
Yes, sir.
How did you get it? Tell me.
Sir.
Yes.
Not God, sir.
Why did you say you got it? Girls, tell them how to do it.
Sir, minimum wavelength equals to 12,400 by V.
Minimum wavelength is equal to 12,400 divided by V. Absolutely correct. You just put the value of 12,400. You just put the value of V. How much is V, bacha?
Sir?
How much is V? Operating voltage. V is the operating voltage.
40 kilovolts, sir.
40 kilovolts. So you divide 12,400 by 40 kilovolts. And here is your answer, beta. Solution, it's very simple. Your minimum wavelength, lambda min, shortcut formula 12,400 divided by V, 12,400 divided by 4T into 10 raised to the power 3, and the answer will be in Armstrong unit, 0.31 Armstrong unit. Do we understand this? Yes or no?
Yes, sir.
Boys,
Yes, sir. Yes, sir.
got it, sir. Chalo, sir. One more question. Let's see who gets this. If you apply your brain correctly without even calculating, you can give me the answer for this one. The cutoff wavelength of continuous X-rays for two Coolidge tube operating at 30 kilovolt, but using different target metals. Target metals are different. We have not talked about target metals, but still I'm giving you this question, and I'm hoping that you would be still able to give me the answer for this one. Yes, anyone?
So 1 minute.
Okay, I give you 1 minute. One minute, I can always wait for 1 minute. If I get the answer in that minute, nothing like it.
Sir, option D.
Option D. Why it took you so long to give me the answer, bacha? Were you calculating?
Yes, sir.
You did not need to calculate because you could have used your brains and gave me the answer straight away. How? Remember this cutoff wavelength. When I say cutoff wavelength, two things you have to understand. Cutoff wavelength means minimum wavelength. Do we understand this? First,
Yes, sir.
now this minimum wavelength only depends on your cutoff voltage. It does not depend on your metal. Do we understand this?
Yes, sir.
So this cutoff wavelength would be same. It does not depend on the metal. There is only one option where the wavelengths are same. There is only one option. And what is that option?
Option D.
So without calculating, you could have given me this answer. And this is the question, that's why I have done, so that you understand that it does not depend on the metal. Now, the only reason you have to calculate this answer would be if there are more options which have the similar answer. Anyways, you can still calculate the value of lambda min. Lambda min is 12,400 divided by voltage. This is 12,400 divided by 30 into 10 raised to the power 3. Even if you calculate, you will get the same answer. Here you did not need to calculate because continuous wavelength, cutoff wavelength does not depend on the type of metal. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
So you could have done this question without what?
Without calculating.
Without calculating this. But then something depends on the type of metal. Something will depend on the type of metal, and that is the next type of X-rays, which is known as characteristic X-rays. It depends on the type of metal that the target metal is. So this type of wave, this type of X-ray, it depends on the target metal. Now, how are these X-rays produced? Just listen to me and understand how are these X-rays produced. Listen to me. patiently. Now see, you can see this electron going like this. It is getting deflected. Because of this deflection, it is continuously losing its power, its energy, and it is emitting X-rays. Those X-rays are known as what? I've asked you a question, beta. Because of this electron getting deflected, moving continuously towards the nucleus, it is losing its energy continuously. Because of this, what type of X-rays are emitted? Hmm?
Continuous X-ray.
Continuous X-rays are emitted because of this. The lambda min for that X-ray only depends on the energy of the electron. It depends on the potential, the operating potential, operating voltage of your X-ray. So it is emitting continuous X-rays by this pink diversion. But in this pink diversion, sometimes what happens? This jig 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 happens. What is the jig 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 jig? What it has done is, while it is moving through the atom of this metal, it might collide with the inner shell electron, and it might give its energy to this inner shell electron, and this inner shell electron can become free. Do we understand this? So that is that green electron which is going out. This electron has been removed from an inner shell. Do we understand this?
Yes, sir.
Now, you must also understand that electron in the inner shell cannot remain empty. Your chemistry tells you that. Yes or no?
Yes, sir.
Now, if your electron in the inner shell has been removed, so this jig jig will happen. This jig jig. Electron from the outer shell will be taking the place of this electron space or vacancy that has been created. Do we understand this?
Yes, sir.
Now, again, your chemistry would tell you that when electron jumps from higher shell to lower shell, or when you give it energy to move from lower shell to higher shell, when it goes from higher shell to lower shell, it emits energy. Yes or no?
Yes, sir.
Those are this jig 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 jig, and those X-rays are known as
X-ray
Cal-
photons.
those X-rays are known as characteristic X-rays, because these X-rays depends on the type of metal. These X-rays depend on the target metal. Depending on the target metal, these X-rays have different wavelengths, and therefore they are known as characteristic X-rays. Do we understand this, or this has gone above our head saying bye bye, I'm going, don't worry about me? I'll give you 2 minutes to note this down. Have you drawn this,
Yes, sir.
No,
boys?
sir.
Okay, I'll wait. Let me know once you're done. Have you noted it down, bacha?
Yes, sir.
Okay, then this is the explanation. If you want to write it in your language, you can write it. How these characteristic X-rays are emitted. Characteristic X-rays emission occur when an energetic electron, the electron which is coming from the zone, collides with the target and remove an inner shell electron from the atom. The vacancy created in the shell is filled from an electron from the higher level. And you can just only write this is just to explain. So what they are explaining here is, if an emergency if a vacancy is created in the K shell, it can be filled from L, M or N shell. If the vacancy is created in L shell, it will be created from M and N shell. If the vacancy is created in M shell, it will be taken care of by the N and the O shell. Do we understand this? This is how characteristic X-rays are produced, and what is the important thing about them? They depend on, so you can write that one as well. Characteristic X-rays depend on the type of target metal. It does not depend on operating voltage. So it is the reverse of the previous one. Do we understand this? I'll give you 2 minutes to note this down. Have you
Done.
noted it down,
Yes, sir.
everyone?
Yes, sir.
Okay. Now, as soon as we understand these characteristic X-rays, now we can see the what? The X-ray spectrum. Remember, most of the question on this chapter will be based on your graphs. So this is the entire spectrum. Do you understand the meaning of spectrum? The band of X-rays coming out of the Coolidge tube. Here what we have plotted is the intensity of radiation. Intensity means the number of X-rays. And here we have plotted the wavelength. As you can see, this graph starts from this point. This point is what your minimum wavelength is all about. On what factor does this minimum wavelength depend on? Minimum wavelength of X-rays which are emitted. On what factor does it depend on? Huh?
Metals.
Operating voltage.
Operating voltage. This lambda min depends on the operating voltage. It does not depend on the metal, dear. So I've said it so many times. Anyways, now you can see these spikes in this. Why are these spikes coming? You have a continuous band, as you can see. As you can see, if I draw it, these are all continuous. Ting. These are continuous. Ting, ting, ting. These are all continuous. Then these spikes are here. These pink are continuous X-rays. These pink are continuous X-rays. What are these spikes? Huh? What are these spikes? There are only two types of X-rays, Gadu. One is continuous. So what is the other one?
Characteristic X-rays.
These are characteristic X-rays. These spikes are characteristic X-rays which are emitted. And these spikes depend on the target metal. Do we understand this, or this is gone above or saying bye bye? I'm going.
Understood, sir.
Spikes? Characteristic? No, I don't have a spike in my hair. No? Some people put spikes in their hair. They are characteristic of their personality. In this, what? This what? Big boss. Some gender, some boy has come of your age. Stanley or something name is. His name is something Stanley or something. He has these spikes on his head. Big head, and something like a Caribbean fast bowler. Spikes means characteristic. Continuous means continuous. I'll give you 2 minutes to note it down. Note it down, fatafat. Have you noted it down, bacha? Characteristics, spikes. Huh? Yes or no?
Yes, sir.
Yes, sir.
Then again a graph. And with this we would finish this class. Again, remember, beta, this is just about your understanding. See, this graph is drawn for two different target metals. but they are operating at the same voltage. Do we see this? This is the exact same question that was asked. Do you remember that question, bacha? This question. Question number 2. Do we remember this? Same operating voltage, but different metals. And you see the graph looks like this. What is the thing that you have to note? That it starts from the what? Huh?
Frequency. Wavelength.
Same wavelength. Because
Wavelength.
this wavelength only depends on the operating voltage. I should not have. This depends on the operating voltage, and as you can see, operating voltages are same. So it remains same. The spikes depend on the metal. And you see here the atomic number of the metal is Z. Here the atomic number is Z dash, which is less than Z. So if the atomic number decreases, then you can see the spikes become more. Spikes go piche. So let me mark them with different colors so you will be able to probably identify them. This lower metal is with the green color. Ding 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 ding. This is the green one. Ding 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 ding. Right? Oops, all my ding ding has gone. Anyways, do you understand this? The upper one is the green one, and the lower one is your blue one. So let me mark this ding 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 ding. This one took, and took. The blue one with the higher atomic number. And since we have talked about atomic number, we will jump on to your favorite topic subject, which is chemistry, in the next class. And we'll see how this X-rays helped someone in making your first periodic table. Who was that person? Huh? You don't know, sir. Talk about chemistry, sir. We don't know physics, sir. So what about chemistry, sir? Moseley's law. The first person who arranged this elements on the basis of their atomic weight. It was then corrected to atomic number, then atomic weight. It was because of this characteristic X-rays we could do this. Anyways, we'll move ahead with this in the next class, and we'll try to wind up your X-rays in the next one. Take care.
Wait, sir. 1 minute. Wait, sir.
Have a nice day. Bye bye.
Sir.